Hello, Calvin here from Let's Count on Math. Let's take a look at BEDMAS today, or order of operations, PEMDAS. There's many different names for it, but basically the sequence of steps that you take to solve expressions such as these. I have the expression written up twice, and let's take a look and see what happens if we do it two different ways. So in the yellow here, if we just did the expression from left to right, let's see what result we get. 4 plus 3 is 7. And then we have the times 5 plus 2 times 3. We carry on going from left to right. 7 times 5 is 35 plus 2 times 3. 35 plus 2 is 37, still times 3. So 90 plus 21 is 111. All right? So if we take a look at that, there's one potential solution for this expression that was originally up on the board. Now let's take a look at the right-hand side. In many math classes, people will remember that you've learned to do brackets, exponents, divisions and multiplications from left to right, additions and subtractions from left to right. So that would mean we have to do 3 times 5 first, which is 15. We still have the 4 plus that. And then we can do these two at the same time. Plus 2 times 3 is 6. So now 4 plus 15 is 19. 19 plus 6 is 25. And you can see that we, of course, get two very different answers. And the thought or explanation that BEDMAS is a convention that we all agree to do so that we all get the same answer is a bit doesn't quite work, because if we all agreed to do it this way, that would imply that this would now be the solution because we all agreed to do it this way. More accurately, BEDMAS has some conventions built into it that's tied to the mathematical language. One of these two answers has to be correct. One of them has to be actually incorrect. And in fact, this is the correct one. So the better way of thinking of BEDMAS is that it's an actual translator for the mathematics that's actually there. It's like learning any language. This 4 plus 3 times 5 plus 2 times 3 that was written up on the board is an expression, just like you could write something in French or in German. And much like learning any other language, the original meaning in the language is the correct meaning. And using an interpreter sometimes to get through the language, sometimes the interpreter can get it wrong. This interpreter is correct. The better thing that we want to get kids to do, though, is to get to the point where, okay, they've learned the interpreter, but just like learning French or German, they now don't have to rely on the interpreter. They can look at the numbers directly and understand what the numbers are telling them. So let's see what that means in terms of let's count on math. To take a look at this expression one more time, and I'm going to give you a physical representation of what this expression actually represents. So let's take a look. There's a 4. 3 of these things called 5. So we actually have this. And 2 of these things called 3. So when you look at the dice faces and you see, okay, yeah, that's that. These are those. That's these two things. This is what the convention part's telling us. We write these symbols because we know what multiplication means. It means of these and of these. So the job of the 4 and the 3 are very different here. They're similar, but they're different. The similarity is that we've agreed in conventions they're coefficients, that's what we call them mathematically, but they're telling us how many of something is there. This is telling us that we have 4 1s. This 3 is telling us that we have 3 5s. 4s and 5s are not the same thing. That's why I can't add the 4 and the 3 yet. These are like cats and dogs. These two dices are different. So it's just like if I said, how many 5s are there? You'd say 3. You wouldn't say 1, 2, 3, 4 of them. You wouldn't count them together because they are unlike things. So here's the idea. If these are unlike things, and I can't add this 4 and this 3 yet, or add in this 2 yet, because these are unlike things as well, we have to make change and see if we can make change so that things will be like. 4 is 4. It's 4 ones. We can see from the 3 5s that this is worth 15. There's 15 ones here. And 3 plus 3 is 6. There's 6 ones there. Now they're all ones. These are all like things. They're cats, cats, and cats. We can add them all together. 4 ones plus 15 ones plus 6 ones equals 25 ones. So that's the basis for Let's Count on Math and why we have to follow BEDMAS. BEDMAS is, as I mentioned, an interpreter, a translator for the mathematics that are there. But once the kids understand what the translator is trying to do, more natively, if we can get them to understand what the math is actually saying, 4 ones and 3 of these things called 5s. That's why I can't add the 4 plus 3. As soon as they understand that, now BEDMAS starts to make sense as opposed to just being a set of rules that they have to memorize and follow.